My name is Guy. This is Kay. We're both program managers in the Azure Compute Core Platform team. What that means is we get to play with lots of cool Azure infrastructure. And it's our pleasure today to show you some of the things that we've been working on, including a couple of things that no one outside of the engineering team has seen before. So we'll have some announcements that you may have heard from other Azure sessions, but we've also got some announcements that are brand new for this session. So I think I set expectations sufficiently high there.
I think that does justice to the session, yeah.
Now, we're also going to be swapping back and forth a few times, just because of the way we've ordered things, but you'll get used to it.
Yeah, not just the walking. And
yeah, we'll probably walk into each other a couple of times.
Yeah,
So let's get started. The way we're going to tackle just sharing this information is to order it in the sense of a set of challenges. I like to think of these as existential challenges. So I don't mean how does one find meaning in a cold, rational universe. It's more a case of if you're deploying an application and you fail at any of these challenges, then it's very likely that your business will fail. Or if we fail at any of these, then Azure's going to fail. So the first one is really about cost. When you're deploying infrastructure, you don't want a one-size-fits-all virtual machine or disk. You want specifically to pay for exactly what you need. So we're going to go through some of the recent innovations in infrastructure. And then another existential challenge, availability. As we know, everything fails. You have to design your application with that assumption in mind, but it's also on us to provide an infrastructure that constantly provides higher availability. So we'll look at some of the recent innovations there as well. Security. It's kind of an obvious one, but security needs to be ubiquitous. It needs to be everywhere, but it also needs to be simple to use. If security is complex, then people make mistakes. The other thing, as well as potentially being everywhere, it also needs to be targeted. In other words, you need the right security where you need it. So yes, security needs to be everywhere, but not necessarily the same type of security everywhere. You need very specific ways to access resources in a secure yet simple manner. And then another existential challenge is managing at scale. If you increase the amount of infrastructure you're deploying, then there is potentially an exponential increase in the complexity of managing it and monitoring it. We need to provide tools that stop that being exponential, make it linear, or maybe flat. So we'll talk about what we've been doing around managing at scale as well. So with these challenges in mind, let's start about infrastructure. So what have you been up to in infrastructure?
Sure, okay. Thanks, Guy. So just a couple of housekeeping notes before we get started. I've seen folks in the sessions trying to take pictures of the slides. Slides are going to be available online later. Just go to ignite.com. So thank you. So I just want to make sure we maximize your time learning here. So focus on the slides and just learn, and then download the slides later. All right, so infrastructure and perf. So there's some things that stay constant in the cloud. Things always get larger, things get faster, things get cheaper, right? But we've always heard from customers, like there's a specific VM type that I need that you don't have. There's a specific VM type that I need for this workload. So let's start off from there, from the VM sizes, and look at what we've delivered since last Ignite. So if we look at the VM sizes we had last Ignite, we had the standard bargain basement A series that was there since the beginning of Azure, but we also had the general compute D series and its second generation, the DV2 series, for general purpose workloads. Then we also had the F series, which offers the same CPU horsepower as the D series, but it is less memory for those customers who don't need a large amount of memory, so they pay less for the same amount of CPU horsepower. And then we also had the largest VM in the cloud, the Godzilla G series, that was introduced two years ago. So in addition to that, we had the H series for HPC type workloads, and these VMs had the RDMA NICs for the InfiniBand NICs. And then we also had announced at last Ignite the SAP large instances that went up to 4 terabytes. So since then, we've introduced a whole set of new sizes. So we've doubled the compute offering since last Ignite. So what we've introduced is the AV2 series. That's the new generation of the A series, offering local SSD for faster random IOs on the local disk. We also introduced the new B series, the burstable size, for workloads that often sit idle most of the time, but sometimes they need to burst up to handle the traffic. And then since you like the first two D series, the first two series so much, we completed the trilogy with the third one. So that offers it's the first hyper-threaded size in Azure. So along with that, it also is the EV3 series. The difference between the two is that EV3 offers twice the amount of memory per CPU core. And then there's the L series for NoSQL type workloads that require a lot of large local disk. So the largest size in this series offers 6 terabytes of local SSD on the VM. And then customers have been always asking for the GPU series, GPU sizes for AI and training, batch training. So we've introduced the N series. And now taking over the largest VM in Azure from the G series is our new M series. That goes up to 128 cores and 3.8 terabytes of memory. That was demoed in Scott's keynote. So, but there are still some workloads that require even more horsepower. So what we've done is made the SAP large instances that we introduced last year even bigger. So now they go up to 20 terabytes on a single node and up to 60 terabytes of memory on a scale-out multi-node mode. So this offers high availability as well. And then on the graph, you'll see 2 years ago our G series and how that compares to our new M series on the RAM and the CPU. And then very large instances fit in and how big this VM really is. So it's not often when your CVP is excited about size. So just wanted to share Jason Zander, who's very excited to be working with this new VM. So another common ask from customers we have heard is like large disk sizes. Like since the beginning of Azure, we've always restricted the largest disk size to 1 terabyte. Recently, we've introduced allowing you to go all the way up to 4 terabytes of disks. But not just large disk sizes, we've also introduced new smaller disk sizes. So now you can spin up premium disks for 32 gig and 64 gig sizes. And you get the same performance you expect from the premium storage, same single-digit millisecond I/O latency. And to go along with these small sizes, we've also introduced a set of Windows Server images that you can use to take advantage of these smaller sizes. So these are 30 gig OS disk images, so they really take advantage of those smaller sizes. Another thing introduced is the nested virtualization for our new DV3, EV3, and M series sizes. This allows you to complete workloads, for example, scenarios where you might require access to the full Hyper-V within the VM, or even for stuff like Hyper-V containers, if you want to run that. It really allows you to pack that VM and increase the density of your infrastructure. Another new capability is the accelerated networking. So this was announced a few months ago. It was announced to be going up to 25 gigabits per second. Yesterday it was announced that now you can go up to 30 gigabits per second. So this is really important for any workloads that are really sensitive to network jitter, or it even offers like reduced latency. And then it's using this technology called SRIOV. So Guy, why don't you tell us about how we scale horizontally?
Thanks. So what Kay just went through, you could think of as vertical scaling. How to deploy big iron, or how to deploy VM sizes and disks exactly as you need them. But what about the key value prop of the cloud is to be able to burst, or to be able to elastically scale, increase the number of compute resources as you need them, decrease them when you don't want to pay for them. So let's take a little detour into horizontal scaling, and then we're actually going to come back to networking in that context. Let me just quickly check. How many people here have heard of VM scale sets? Okay, I'm seeing most people. How many people have deployed a VM scale set, just out of interest? Quite a few people. So I'm not going to spend a lot of time on the very basics. But I think the core for VM scale sets is that you get to centrally define the compute, the network, storage, and also the capacity. In other words, the number of VMs you want. So you can define a scale set just like you define a VM, but then you can change that capacity value and you can scale out to 1,000 VMs, or you can scale back down to 0. That capacity change is very easy to do, so you can integrate it with auto-scale as well and just scale on different metrics like CPU usage or number of sessions, for example. So that's the real key. So what do people use that for? If you're deploying more than one VM that's configured the same, then you can start to get use out of scale sets, because it's just one command to do operations on any number of VMs. If you need to scale a lot, change the number of VMs, you get advantages of scale sets. But what about if you need to deploy massive scale, like 10,000 cores, hundreds of thousands of cores? Then you have to do a lot of work without using scale sets. With scale sets, it becomes much easier. So I did some extensive research on Twitter, and when you see examples like this, Elon Musk is talking about the collaboration between OpenAI and Azure. Under the hood, that's a lot of scale sets doing a lot of work. This is a massive infrastructure deployment. It was made manageable using scale sets, very large scale VM scale sets. So that's a good example of deploying at massive scale where you have to worry about things like throttling. You have to, in a normal world, you'd have to worry about managing lots of storage accounts, things like that, correlating with different network resources. With scale sets, you can just centrally define these things, so it's much more straightforward. So now I'm going to go a little bit deeper on scale sets and talk about the concept of a scale set model versus a VM model. Now, there's a good reason for doing this, because it's very relevant to some of the things that we're going to be announcing. So the traditional view of the scale set, this is actually a screenshot from Resource Explorer, where I'm just looking at the definition of a scale set. And you can see, for example, it's defined the VM size, it's defined the capacity. The way a scale set works, which is its core strength, is you define this model, and then you effectively, all the VMs conform to this model. That's what makes it easy to centrally configure. You define it once, you apply it everywhere. Of course, that does potentially present challenges as well, because when you deploy a resource, in terms of the REST API, it's a put. You put this JSON body of a definition, and you deploy that resource. The scale set model, you can't do a put on an individual VM. So if you wanted to do things to your individual VM, like assign a public IP address or attach or detach a disk, you weren't able to do that. You had to all the VMs had to be the same coming from the scale set model. You could define attached disks, but not like different for individual VMs. So that's the current state, and in a sense what we're announcing now is what you could call a revolutionary change to that, the ability to put configurational changes to the VM. That way you can treat it just like a regular VM in an availability set, but still with all the advantages of being able to scale it. And that's an indication of kind of convergence that we're doing with VM scale sets and VMs. Just in a sense, there may be some point where you don't really have to differentiate. You can deploy a VM and it's scalable. So that's our goal. I'm going to start with a very simple demo, and honestly, I have no idea which button switches to my machine.
I think it's that one.
That's preparation for you, thank you. I'll start with a very simple demo, which is creating a scale set. I think a lot of people are familiar with this, but you may not have seen the new UI that we just added for creating a scale set. So this is going to be like a 1-minute demo. I'm going to click New in the Azure portal. I'm going to click Compute, and one of the featured resources is a virtual machine scale set. Now, when I go there, let me make the Cloud Shell, which we will be using later, a little bit smaller. What you see here is just a very simple vertical pane. If you've deployed a VM in the portal, you may notice that you've got lots of little sidebars you need to fill in, you need to go and choose the size. It actually takes a while, multiple different screens. This is just a new, much simpler vertical create that we've already moved to with scale sets, and we'll be moving to with VMs soon as well. And I guarantee it will be much easier. If I look at the things that you fill in for a scale set, yeah, there's the scale set name, there's the operating system. This is basically a platform image that will then be applied to all the VMs. The subscription, the resource group, the location. Then you see this new thing. Do I need to maybe magnify it a little bit? We've got availability zone preview, and I can click on that. And I can click, we have a choice of availability zones. Keep that in mind because we'll be coming back to availability zones. This is a feature you may have heard of announced Friday, but we'll be talking about this in more detail. And then the other key feature for scale sets is the instance count, how many VMs I want. This can be up to 1,000 for one scale set, but of course you can always treat a scale set as a scale unit and deploy multiple scale sets as well if you want larger infrastructure. So that's all I'm going to show you for this very short demo. And if you could move us back, so that was 6. All right. So I said we'll get back to networking. So one of the things that when we introduced scale sets, this was in March 2016, we had a lot of requirements. There were a lot of networking features being implemented for VMs at the same time, but because of the timing, they weren't available in scale set VMs. So we fixed that a couple of months ago, and also provided a feature that starts to go beyond merely stateless like pets versus cattle, the ability to have a public IP defined for every VM. This is useful if you think of, say, you've got a resource in the cloud doing game physics for a massively multiplayer game, and you've got a load of consoles. You may need to do direct public IP connections from the console to the VM doing the game physics. You don't really want to go through a load balancer for something like that, so we had requests from gaming companies asking us to provide public IP per VM. Another example of public IP per VM is, say you've got a globally distributed database where you want VMs actually that are database nodes or connection nodes to be able to communicate with one another across regions. There, you generally need something like public IP per VM. Now, there's other scenarios people are asking us for as well. Let's think of a web application firewall. So let's say there's firewalls like Brocade available in the Azure Marketplace, where they need things like multiple IP addresses per NIC, multiple NICs per VM, but they also want to do auto-scaling. They want to scale out the capacity of this web application firewall at the same time. So they need that combination of these networking features and scale sets. So all of these features that you see here, they're now available, including accelerated networking that Kay just talked about. And now, of course, scale sets are mature. When the networking team introduce new features, they generally introduce them for scale sets as well. So you've got that parity with virtual machines and scale sets. Now, I did some more intensive research to find an example of using these networking features. So I mentioned distributed database. So here's a tweet from Ben Luckey at Couchbase. They make a great distributed database that can be potentially global. And they have their sync gateways that need exactly that. They need to scale. Basically, they need you to be able to just use a scale slider in the portal to increase the capacity. But they also need direct connection. So this was perfect for them. Once scale sets and public IP per VM were available, they could do what they wanted to in the cloud. Okay, I'm going to hand back to my esteemed colleague to talk about availability.
Cool. So we talked a little bit about infrastructure and perf. The other key tenets everybody wants in the cloud is a high availability. So let's talk a bit about what we've done. So since Azure started, customers have had to think about storage in terms of these storage accounts. And inside these storage accounts were the page blobs. And so storage accounts had their limitations, which meant you had to architect your compute architecture around these storage account limitations. One of these limitations was, for example, a storage account could only serve like 20,000 IOPS max, which meant you couldn't do more than 40 VHDs or 40 blobs running at full 500 IOPS per blob storage account before your VM got throttled. So we've worked on this thing called managed disk. This is a new feature that we're introducing. So what managed disk introduces is a concept, is a management concept for objects such as disks, images, and snapshots. So the way this works is, and here we go. So the way this works is, we take away the control of the storage accounts and the blobs away from the customer, and all customer interacts with is the disks at an object, disks, images, and snapshots. Now what the benefit this offers is, this abstracts the storage account away from the customer. You don't have to deal and worry about those storage account limitations anymore. You can get RBAC access on these objects because they're a top-level ARM resource. They're secure because there's no public access to the blob. You actually have to go in and generate a time SAS token if you actually want to get access to the blob. So by default, there's no public access. And then they also support VM-level disk encryption, and the data is encrypted at rest through the storage account APIs. And then it also provides better storage resiliency. And let's talk about this last point. How does it provide higher availability to your VMs? So in the past, I want to take a look at if you had VMs deployed with unmanaged storage. So in this case, what I have is I have 3 VMs deployed in one availability set, and all of these VMs have a disk each, OS disk each. But if you look closely, all those VMs are in the same storage FD. So Azure has this concept of fault domains. Essentially, think of those as different racks. So if one rack goes down, it is usually takes down one VM. But because storage FD, all of these VMs are in the same storage FD, so that storage rack going down could take all the 3 VMs going down. Now, with managed disks, what happens is we align the VM FDs along with the storage FDs. So VM 0's disk will be in storage FD 0, and then VM 1's will be in storage FD 1. So that's when one storage FD goes down, it only takes down one VM, not your entire application. So to get you to the latest and greatest, what we've enabled is an easy migration path. So a lot of your VMs are going to be in this unmanaged state. So it's very easy. It takes less than 5 minutes to get that VM to managed disks. All you need to do is stop the VM and then run the conversion commandlet in PowerShell and CLI, and I'll show in the demo the portal experience for that we'll have coming up soon. And then the VM reboots, and when it starts back up, it's a managed VM with managed disks. The other benefit it offers is, for a long time, customers have asked, hey, can I switch my drives from my storage account from standard to premium? The way you would have to do in the past is to copy the data over, create a premium storage account, copy the data over. With this, all you need to do is update the type of the disk from standard to premium, and it happens less than 2 seconds. That's how fast it is. So converting the VM from standard to premium is easy as well. All you need to do is select a size for the VM that supports premium storage, change the disk from standard to premium, and then reboot, and the VM will be on premium storage. So let's take a look at some of these capabilities for managed disks. So just to level set, let's look at the way the world was before managed disk. So I'm showing a storage account. A storage account would have had blobs in here. So if I click on blobs, this will list all my containers in this view. And then if I list my containers, so a blob, here's a blob, for example. It has a URI. Let me just zoom in there a little bit. So it has a URI that's public that you can hit and download. You can provide access to it and download that blob. So with managed disks, for example, if you want to get a VM to managed disks. So here's a VM that I've created. And then I've already stopped deallocated it for the purpose of this demo because that takes a bit of time. I will click on the disks property for this VM in here. And if I click on the OS disk, you'll see that it has a VHD URI, and it's pointing to a blob that's sitting in a storage account. So to convert this VM to managed disk, this is a preview of a portal experience. There'll be an option in here that says migrate to managed disk, and let's hit that. So there's some information about what managed disk does, and so this migration is irreversible. This is only one way. So all you need to do is click migrate in here, and this is going to perform a few steps, and this should be done in a few minutes. Okay. So let's talk about managed disks themselves. So looking at this resource group, I have 3 objects in here, 3 managed objects in here. So the first one is a managed disk. The second one is a managed snapshot. And the third one is a managed image. So the managed image was captured from a VM. Snapshot is like a point-in-time snapshot of a managed disk. So I showed you it's easy to switch a disk between standard and premium. So to show you that, let's click in here on the disk properties itself. So if you look here closer, the account type of the disk right now is standard. All you need to do to change it to premium is just select premium in here and save. And this is going to be really quick, so take a look on the right-hand top corner. So it's going to be updating disk and successfully updated disk. So the disk is now a premium disk, and you can see it reflected in here. So that's how quick it is to change a disk from standard to premium storage. So let's continue, see more stuff about managed disks. So how do you create managed disks, right? So the way you can create a managed disk is go to new and just search for managed disks and hit create in here. You can give it an empty name. So in this case, all I'm doing is I just want to create an empty managed disk of certain size. I'll use the same resource group I was using earlier. So source type, let me zoom in here a little bit. So source type, you get 3 options for source type. You can create a managed disk from an existing snapshot. You can import an existing storage blob. So remember the blob I showed you earlier? I could import that into this managed disk as well and make a managed disk out of that blob. But in this case, I'll choose just an empty disk and I'll create a size. So because I'm choosing premium, it also gives you nice estimated performance for that blob once I create. So if I want the maximum performance on premium storage, I'll create a large enough disk. In this case, a little larger than 1 terabyte, and I should get maximum performance from that blob, from that disk. So click create. So that should take about a minute, and you should have an empty managed disk created in that resource group. Now, the other way you can do is, so I mentioned you can import an existing blob. So let's just quickly do that as well. Existing, so I'll use the same resource group, premium, and I'll choose a storage blob in this case. And so I'll go to browse. This will give me a view of my storage accounts. So I'll choose one of the storage accounts I showed you earlier. Give me the containers, and I'll go down to this blob down here, which has a Linux OS on it. So I select that, tell Azure that my OS type on that blob is Linux, and then I can create a blob of, for example, I just want like 30 gigs in this case. So that gives me gives me an estimate of the performance I can expect out of that. Looks like there's a problem. Okay, so a little bit larger than 51. So that should work. So that's how you can create a managed disk out of an existing blob. So let's go back to the VM that we tried converting and see where we are. So it looks like that VM has completed. So it's successfully migrated the virtual machine to managed disk. So that virtual machine is now using managed disk, and if it's an availability set, and there were multiple VMs in the availability set, those should have their compute FDs aligned with the storage FDs. Okay. Let's switch back to the presentation.
So that was nice. Is that available now?
That is available now, yeah. That went GA earlier this year. It's completely available to use and use in your production workloads. All right, so Guy, why don't you tell us how we can use managed disks with scale sets and what are the benefits they offer?
Sure. So with unmanaged disks, we had a scale set limit of 100 VMs. And even then, you had to create 5 storage accounts and manage those storage accounts. Because of a property called over-provisioning, which improves the reliability of scale sets, but it actually limits you to 20 disks per storage account. We had the problem of, we want to have scale sets that are 1,000 VMs, but we don't want people to manage 50 storage accounts. Managed disks let us get over that. You don't have to manage storage accounts anymore. You just define the storage properties in your scale set. a lot of people deploy applications using custom images. And because of this storage account limitation, we had basically a limit of 20 VMs in a scale set with custom images. We've increased that to 300. You may ask, why not 1,000? And this is partly because there are multiple copies of platform images in our regional platform image repositories. A custom image, you basically upload one copy. So there's a little bit more work needs to be done, but definitely our long-term plan is to increase the scale of custom images as well. Now, 1,000 VMs, I just included a little screenshot. I'm not going to go into much detail, but you could think of a scale set of 1,000 VMs as being like a scale set of 10 availability sets. So you've got this set of entities we call placement groups that have fault domains within them. So within a placement group, you can use fault domains and you've got isolated hardware. So that's sort of how we scaled out to 1,000. Now, we're currently looking at scaling out much further, and some of the other technology we'll be talking about will show you how we can get there. What about parity with VMs, though? I mentioned with a VM, you can just attach a disk and detach a disk, which is very useful for a lot of applications. With scale sets, because you're not able to do this put on a scale set, then that becomes difficult. So that's one of the things that we are announcing today, effectively, is this ability to put a configuration onto a VM within a scale set. And we're starting with the ability to attach and detach a disk. So let's take a look at that. And like I say, no one outside the engineering team has seen this yet, so I hope it works. So here I have defined a resource group. And within this resource group, I've defined a managed disk. So I'm going to call this disk float because I want to be able to attach it and detach it to different VMs. So it's a 20 GB disk. And if I go back to this resource group, it doesn't have to be in the same resource group, but I also created a virtual machine scale set. And this scale set is, if I just zoom in, it's basically standard D1, V2 with 2 instances in it. Now, first, let's RDP to the first VM. And in this VM, I'm running the disk manager. And the disk manager says basically it has a C drive and a D drive. It has a temporary drive. So let's see if we can attach a disk to it. Now, currently this is available for REST API. We haven't built out CLI, PowerShell. Like I say, this is early stuff, but we do hope you'll be able to use it this year. So I'm going to call the REST API directly. I've got a couple of little Python programs to call the REST API. So I'm going to run a program called attach. And let's just zoom in and see what it does. So this is just really showing the information that I need to provide to the API. I need to provide the name of the scale set, which is gbdisk, the name of the resource group, which is also gbdisk, the operation I'm providing, which is attach, and then the VM ID, I'm attaching to VM ID 1, the LUN, so the disk LUN, I'm attaching to LUN 2, and then give the disk a name. So I'm going to call it disk float. So I want to attach that. So let's see if we can attach it. Now, if this works, it's going to spit out a load of JSON, which is the configuration of the virtual machine. And it did, which is a good sign. So there it kind of basically spit out the VM configuration. Let's go back to our RDP session. Let's see if we can refresh. And I'm just going to go check that it didn't spit out an error message. So it did say, I do see data disks, LUN2, disk float attached, so it's definitely attached to the VM. Sorry? Oh, let me try that. For some reason, I thought, oh yeah. For whatever reason, just refresh. In fact, sometimes I didn't even need to press anything when I was practicing this, but I'm glad I've got a disk manager expert in the audience. So I rescan in this case, and disk 2 now shows up. Let's look at File Manager and go look at this disk. So there I see it, my floating disk. And I see, actually, in this case, I already initialized this disk, and I'd put a file on it. You could attach a raw disk. You could attach a disk with a file. So this file says read this, so I better check. Hello, I'm a working demo of a VM level attached disk. Great. And then why don't I detach it as well, just to show the second part of the demo. So I've got a similar script which called detach. And in this case, I provide the same information, except that I don't need to provide the disk name. I just provide the LUN that I'm detaching the disk for. Now, you may think, what if it clashes with the VM scale set model? What if I'm attaching a disk in the model too? And the basic principle we operate is that if there's a collision, then we fail the operation. So if you can't attach a disk over a disk you've attached to the VM. There's probably more complicated edge cases which we'll document, provide full detail. But the basic operation is so you don't accidentally lose data. So I'll run the detach script. So that ran, it printed out the new VM scale set model. So let's go back to our RDP session. And yeah, in this case, it's already gone. So the disk, it was detected that it's been detached, so it's no longer available. So like I say, this is kind of a revolutionary change for VM scale sets, and something that we'll be looking at for other properties as well, that you can just treat a VM like a regular VM. So let's go back to ZIP5. Now, how many people here went to the session yesterday by Saad Ladki about availability zones? Okay, a few people. If you didn't go, you can be forgiven because it was embargoed session, so there was very little information about it. But that was where, for the first time, we went into detail about this concept called availability zones, which were basically announced on Friday. So finally, you have a simple way of understanding availability in Azure. Availability zone is basically a set of separate data centers within a region that are all close together. So with separate power, basically zone isolation services, independent network, etc. So because of this, you can basically achieve full resiliency. As it is, we have paired regions, so you can have an application that's doing data replication between two regions that are close together. But now you've got, within that region as well, you've got this concept of 3 availability zones. So because of this, you get protected. What you didn't have before is you're protected against an entire data center loss. And because of this, we're really setting standards with the SLA for applications. So basically, we've got the best SLA in the industry now for high availability with 4 nines SLA. I strongly recommend you go dig up this session. We will be demoing availability zones, but this one actually takes it to another level. It's a whole session all about availability zones. It's very important, something that's very useful to understand with the concept of availability. So just talking about that resiliency and the SLA. So now you have several choices. Something that you see very rarely, if at all, in the industry is an availability SLA for an individual VM. We never used to. We used to say there was an SLA for 2 VMs in an availability set, which we still have, but now a single VM has a 3 nines SLA as well. That's just because of the incremental reliability improvements we've been doing in our own data centers and operations. For 2 VMs in either availability set or a scale set, there's now this 99.95 SLA. Again, really standard setting. With availability zones, you get, with this additional protection, we're giving this 4 nines SLA. And then, of course, we've got this industry-leading disaster recovery with 42 regions. This number just keeps getting bigger every time we do a talk like this. I've included a link here, and you'll get the slides for more information. This is the original announcement that we made on Friday for availability zones. So availability zones is currently in preview. What does a configuration look like with availability zones? Well, There's also the concept of a zone-redundant load balancer. So the load balancer, also in preview, has this new SKU called standard. So if you configure load balancer standard, it can be zone-redundant. So here's an example of you can pin a VM to a zone. When you create the VM, you now have this zone drop-down that you can choose from. So you could create 3 VMs, pin them to different zones, and then have a zone-redundant load balancer. So you've got a very available app at this point, doing your load balancing or whatever you need to do. And then you can also, in public preview, you can make a scale set zonal. So as you saw when I showed you creating the new scale set experience in the portal, you can pick from this drop-down the zone that you pin a scale set to. And the new zone redundant load balancer can actually load balance between different scale sets. Now remember, a scale set in a zone, it also has the concept of fault domains. It's also highly available. So it also has that high availability SLA with it. And then, of course, you can have up to 1,000 VMs per scale set. You can have features like public IP per VM. So you put all these together, it's a real change in the way that you can create applications for high availability. Now, currently available in limited preview, and here's a link where you can sign up, is the concept of zone redundant scale sets. So here, you can create a scale set, and instead of picking a zone to pin it to, you can just put it across all zones. So now, here's like the scale set VMs in one zone in their different fault domains. You can have them in multiple zones as you create your scale set. So again, one scale set then becomes super resilient and reliable, and the load balancer can just balance between these VMs. Now, what they did in yesterday's session, they actually demoed a load balancing web app, which then queries a zone redundant scale set using this new load balancer SKU. So if you want to see that application level demo, go see it. Now I'm going to show it more what's happening at the infrastructure level demo of scale sets. So let's take a look at that. 6, please. I'm sorry. So back in my portal, I've already showed you the create experience for a VM scale set. And the create experience for a VM is the same drop-down. I probably don't need to show that again. But what I'll do is I'll go and look at an existing scale set that I've pinned to a zone. So I've imaginally named it one zone. And let's zoom in here. This is all the difference that you really see. You see that it says East US Zone 1, East US 2 Zone 1. So now you know this scale set is pinned to that zone. And then if I go look at this other scale set that I've created using the private preview, this is called M zone. And if I go in, it says East US zones 1, 2, and 3. So you know it's a scale set distributed across zones. So I'll show you one more thing, which is what do these scale sets actually look like in terms of where the VMs are in the actual zones. So I'm going to run a program here, if you bear with me. All this program is doing is just it's a Python program which is querying the VM model and saying what zone are you in. So it's just making REST calls. And if I go to this one zone VM and show the heat map, it's just queried every VM and asked which zone are you in. So as you can see, all the VMs, there are 10 VMs and they're all in zone 1, spread evenly across different fault domains. In other words, like different racks. Now let's go and look at this multiple zone scale set, show the heat map. And you can see that it has spread itself evenly across fault domains and across zones. So what this means is I can do operations. For example, let's say I pick zone 2 and I power off zone 2, simulate, which is a nice easy way to simulate a zone failure. If I'm connected this with a zone redundant load balancer and I've got an application serving it, then it becomes very easy for the application to keep running. Now I'm just going to, if I show the heat map, you should see these VMs starting to go down. They're just color-coded for different power states. So these VMs are starting to power off, but you can have a good feeling that your application distributed across zones is still perfectly good, because they'll just drop out of the load balancer pool, but the load balancer will keep running them. So for the application level view of that, you can catch the video of yesterday's session, and I will switch back to the slides and pass over to Kate.
All right, cool. So let's continue on this availability story. So you've seen how to architecture applications and how availability zones provide redundancy to your applications. Now, what high availability and hardware failures, those two things don't go together, right? But hardware failures are a fact of life. So I was just at the booth yesterday on the expo and was talking to a customer who's having a hard time. They're running in their own data center, and they're having a hard time explaining and proving it to their software vendor that their hardware is not the issue, it's the software that's the issue. So that's a challenge they've been having, and he's been in and out of Ignite here for the past 2 days, and the application is still not working. So that's the kind of headache they're dealing with. So that reminded me of what we are doing in the cloud to make sure our customers are not running into those kind of challenges day in and day out. And all you are doing is focusing on architecting your applications, and we are focusing on making the hardware highly available. So when you run servers at like million servers, you get a lot of telemetry a lot of hardware level telemetry coming from those servers. And hardware fails every day, multiple times. So what we've done is we've seen the patterns we observed before that hardware fails, and we've applied machine learning algorithms to those. So what we can do now is we can actually predict when a hardware is going to fail, and we can go back to the OEM and tell them, give reports of what the hardware is failing, what are the failure rates. And for the customers that are deployed on the failing hardware, we can actually move them over to a healthy hardware. So we are testing a live migration in certain regions, so once that works, that will be deployed generally. So that way your VMs don't go down, and your VMs applications continue to be highly available. So another thing we're introducing is something called planned maintenance. So for a long time, few years ago, we used to reboot for a lot of these security issues, security patches, and a lot of these patches. But since then, we've developed a technology called host preserving update, in-place migration, which means that we pause the VM for 30 seconds and we replace the OS underneath the VM with the new updated OS. So we don't reboot the VM. The application just sees a 30-second pause, and it keeps running after 30 seconds. But sometimes we need to actually do a full host reboot. For example, we'll have one coming for when we do Windows Server 2016 on all the fleet. So that's where we'll need to do a full host reboot. So we've announced this capability called planned maintenance. It's available right now in West Central US. If you deploy a VM there, you can actually see this experience live. So you'll instantly get a notification. So what this experience is, customers get a notification of for 30 days. Basically, pick a time where you can reboot and set up other activities in your organization around that. But if you don't, then we'll do the reboot for you after that time window expires. So this provides an easy way for customers to take control of their maintenance windows. So just to round out, using that, we provide industry-leading SLAs for single instance for availability set, and for now at GA for availability zones as well. So for other highly available features that we have integrated into Portal is backup integration. It's really easy to take backup set up a regular backup for your VM. All you need to do is go to the VM properties, VM Blade in Portal, and hit the backup properties, and it's really easy to set up backup from there. Now, along with backup, we've also enabled site recovery integration. So you can actually set up the same easy way, set up site recovery replication for your VM to another region. Basically, this is all you need to do. You just select a region and basically hit enable. And then your VM is automatically replicated to another region. So let's talk about the third tenant in cloud, the security. Security is top on everybody's minds with what's happening out there these days. So last month, we introduced this confidential computing. So Intel processors have had this trusted execution environments, these enclaves, where you can put data in and it can be computed securely. And basically, we don't have the key for that, whatever data you put in there. So this allows customer to put like really, really sensitive data through that hardware enclave and get execution result out of it securely. So this really prevents you against malicious insiders, malicious admins that might be trying to hack your application. So you wouldn't want to put all your application data in here because this is a black box to everybody. Like even the debuggers don't work. If you try to debug your code, you will just see a bunch of encrypted bits. So this is for the most critical workloads. So the other thing we introduced is managed service identity. For a long time, customers have wanted to access their other Azure applications from within the VM. And the way they would have had to do this in the past is set up a service principal and put the credentials for those service principals on the VM itself, which is not a recommended way and not a secure way at all. If that VM gets compromised, those credentials get compromised to your other Azure resources. So what managed service identity introduces is a local endpoint within the VM that customers can call, application can call to get an AD auth token to all your other Azure resources, or you can actually give it access to whatever other resources you want. So, and it's easy, very easy to turn it on for any existing VM. All you need to do is basically yes and no flag that needs to be turned on. So, Guy, why don't you tell us about how MSI is being used in a few different places?
Thanks. So I'm going to talk about a couple of big problems, big applications where MSI was really indispensable, where you just couldn't afford to do things like have a service principal on the virtual machine. So the first case study involves the European Centre for Nuclear Research, CERN, the Large Hadron Collider collision analysis. So the Large Hadron Collider generates ridiculous quantities of data, and there's research teams all over the world doing analysis. Now, there was a collaboration. It was between the University of Wisconsin, the Tata Institute of Fundamental Sciences in India, and the CAT team. They all worked together to find a way to solve the problem where there's this high throughput computing system called HT Condor, where you can issue simple commands, you can deploy resources, but what it really needs to be able to do is to burst to regional data centers in the cloud. That way, you can just deploy cloud resources when you need to do this analysis, and when you're not using them, you don't have to pay for them. So they came up with this system. It was called GAP, which is Grid ASCII Helper Protocol, which then you can issue a set of commands, and then these commands, they can go to on-premises machines, but they can also go to the nearest Azure region where there's a resource group. And then you've got virtual machines, you've got virtual machine scale sets, which can then span out and do the work. But these machines, they need to get access to confidential data that they shouldn't be able to get hold of if they're not in the same resource group. So the most convenient way to do that was to actually use the Managed Service Identity, MSI, to assign rights to all the VMs. So these VMs get an authentication token, and then they can get keys out of Azure Key Vault using that authentication token, and then they can go and download the information that they need to run. It's just one of those solutions that you could have probably found a way to do it, but it would have been a real hack and probably not as secure if you'd used something like Service Principal. So it's a good use case for MSI. And being able to do a collaboration like this, it really opens up Azure as a bursting platform. There's more than 170 institutions that collaborate with CERN that can use this same HT Condor software. So it's a really useful partnership. Here's another big use case for MSI. It's one we had to use ourselves because supporting disk encryption for virtual machine scale sets, that's actually potentially a tricky problem because when you encrypt a VM, it generates a set of unique keys. So imagine hundreds of VMs in a scale set, you've got hundreds of unique keys. They need to be stored somewhere because when a VM reboots or something, it needs to be able to attach and get its encryption keys. So it needs a certain amount of privileges to get its keys from a key vault. So that's potentially a tricky problem. And let's work through how it works. If you start with a scale set and an operator, you create a key vault, and you can set this key vault so that it has access for scale set encryption. So the operator issues command. I'll show you what these commands are because this is something that's currently in preview. Issues command to encrypt a scale set. Now these commands, they go through the resource manager, they go through the host, an encryption extension is deployed onto the scale set. So at this point, let's say if it's Windows, it's BitLocker, it starts running and encrypting the scale set. And then the scale set storage is encrypted. It's encrypted in Azure Storage, so therefore it's fully encrypted. And then you need to get those keys. So you use MSI so that the host then gets an AAD, gets an authentication token, and then it can upload the key to the key vault. So at that point then, the scale set can reboot, and it can then get its keys. So again, a nice simple solution to what's potentially a really complex problem so that you can do disk encryption for scale sets. Why don't you just encrypt the storage account? Well, if you encrypted the storage account, then if the storage account is compromised, you don't have access to it. If you encrypt the whole VM, then the storage account can be compromised. Somebody could steal the VHD as well, but they still wouldn't have access. You would actually have to go through the authentication process through to the VM to get access to that data. So it's more secure than simply encrypting a storage account. So as I said, it's in preview. Very soon you'll be able to self-register. I think it's only in Canary regions as of today, but very soon this will be available. And we've already built some PowerShell commands just to basically get the encryption status, disable encryption, set encryption, etc. So we're moving ahead very fast with this encryption. So now we'll move on to manageability and monitoring. This is where, how do you avoid this exponential complexity? Well, let's think about horizontal scale again. So with horizontal scale, some of you may be familiar with cloud services, PaaS v1, worker roles, web roles. Anyone who is probably misses the fact that they didn't have to worry about the operating system version. They didn't have to worry about patches. That all got taken care of. Now, when scale sets were introduced, this is very much infrastructure level. We didn't take care of things like the operating system version. We kind of said, well, we provide primitives that can re-image, that can upgrade an individual VM, but you're kind of on your own to script that out and take care of it. But obviously, this is particularly for people who say, how do I go from cloud services to Azure Resource Manager? I need a solution like this. I need a PaaS platform, or at least a platform for PaaS services. So this is something that we've been working on. So another announcement that we have today is support for VM scale set rolling upgrades. So a VM scale set rolling upgrade, when you configure your VM, you can set it to rolling. So you can update your scale set with a new version. And then, sorry, this is a bit small, but there's an optional rolling upgrade policy, which is, it gives you options like the percentage of VMs to update at a time, like a batch instance percent, which defaults to 20%. There's a max unhealthy instance percent, so if this percentage of VMs is unhealthy, then stop rolling forward and, in fact, roll forward the original version. There's a max unhealthy upgraded instance percent, and then there's a pause time between batches. So then you can integrate this with, in fact, it comes with integration with a load balancer, so you can have a load balancer probe checking if, at an application level, if your application is healthy. And then, so here's an example probe. So it just works like a regular load balancer probe, so you can introduce application health as well in your scale set. So this is what you might call a manually triggered rolling update. Let's do a quick demo of that. Now, I'm in the Resource Explorer, resources.azure.com, a very useful tool. And I'm looking at this scale set called zroll, and I'm just looking at this definition, and I'm going to go down to the definition where it has the OS version. Let's just zoom that a little bit. So this is an Ubuntu server 1604 LTS, and instead of just having latest version, I have a specific version in there, which is 1604 and then lots of numbers. I'm going to change this version. So I will go in my Resource Explorer to Edit. Go and find this version. And I'm going to change the 08151, which was the August release of Ubuntu 16.04. And I'm going to change it to the September release, which is 9190. So I've changed that version. And I'm going to go and do a put. So I'm basically updating the scale set configuration. Now, if we look at my configuration, I'm going to go, I see that there are some extra things here. There's a health probe ID, for example. And if I look at another section, it's a cross-zone. It's a cross-zone scale set, and I have a zone balance equals true, which will, if there's a disaster, then it's a way of keeping the scale set working if the zone goes down. And then up here, I've got the rolling upgrade policy mode equals rolling. Now, I don't have to include those rolling upgrade policy settings unless I want to change the defaults. And then I've got automatic OS upgrade equals false. I will talk more about that in a second. So because I've set this and I've gone and updated it, if I go into PowerShell now, I can run a PowerShell command, which is called upgrade status. So all this does is it calls a new PowerShell command, which is get Azure RM VMSS rolling upgrade, and it'll basically ask it, have you been doing any upgrading lately? So if I run this, here is actually, it says right now it's rolling forward. So it started just now, and currently it's, well, there's one instance in progress, and there's a whole lot of instances to go. As it gets going, it's going to be doing more instances at a time. Now, if I actually go and see what the actual VMs are doing, and if I click on refresh, I'll see if any of these machines are actually showing us. So it looks right now it's transitioning between two updates. All the machines are online, but I won't sit waiting while they all go through, but basically you can see these VMs in batches, the batches that I've configured going through now and upgrading. So that's the basic status. Now if we go back to the slides, please. You could be forgiven for saying, yeah, but I want fully automatic OS update. I don't want to have to worry about the OS at all. I don't want to just manually trigger a rolling update. So now, in preview, and again announcing this for the first time, is we have the concept of automatic OS upgrade for VM scale sets. So this is real set it and forget it approach to OS management, getting much more like a platform as a service. So yeah, you've got the same optional configurations like batch size, the instance health thresholds, the load balancer probe for application health. We're also working on portal integration, so you just be able to configure this stuff from the portal. Right now, you have to register this as a feature. So for any of these, I've included a link to our GitHub page where we're managing the upgrade, or you can just contact me and we can get you into the preview if you're interested in this. Now, initially, oh yeah, I should probably also mention that what this picture on the right is. There's this entity called a Regional Service Manager. Now, don't get used to that name because it's probably going to become a zonal service manager. But basically, this is a new service which handles the automatic upgrading for you. So now this will check the platform image repository for the latest platform image for a given SKU. Then it triggers the automatic upgrader, which basically updates the scale set model. And it will check the versions as well to check if the image on the scale set is older. So that's the Regional Service Manager that you won't hear about. But we may be talking about a later iteration of that, the Zonal Service Manager. But you can start using it right now. And then, so to configure automatic updates, this is really just one small difference for that rolling. This automatic OS upgrade equals false. Set that to true. That's really the basic configuration. And from then on, this Regional Service Manager will then start going and looking for the latest versions of these platform images and start upgrading them. So that marks a real change in the direction of scale sets, or at least a real increase in the scope of scale sets to moving up the stack towards platform as a service, and something that our cloud services users have been asking for a long time. So yes, we're definitely working on supporting all these kinds of applications. And then for this preview, we're only supporting currently 3 OS versions: Ubuntu 16.04, the Windows Server 2012 R2 Data Center, and Windows Server 2016 Data Center. If your favorite operating system is not in this list, come talk to us. I mean, it's in a sense, we're responding to demand, and we're also taking OS providers that provide regular monthly updates. We're kind of favoring them initially, but we'll definitely be expanding this list during the preview. And eventually, we want your custom images to work with this infrastructure as well, although that's looking further out. All right, I'll hand over to
All right. Kane. So let's talk about another exciting capability that's available now. Another problem that's customers have had is querying the information about the VM from within the VM. So it's always been available from outside the VM, but how do you know the public IP of the VM within the VM? So now there's an easy endpoint, standard industry endpoint 169.254, that you can call and you can get information about the VM. So hopefully that is Windows large enough, but this is the kind of information you can get back. So you can get back the VM ID, you can get back the public IP address and the other networking information about the VM. So this makes it really easy for your applications to know what VM they're running on and know a little bit about the architecture, the data center level architecture of the VM. Another property right down, I think there at the bottom, is scheduled events. That's where if a VM was, so for example, I mentioned if a VM hardware was failing, we move the VM to another hardware. That's where we'll send a notification to the VM, and your application can respond on that event and take actions before that VM is rebooted to another host. So as part of this, rounding out this portal improvements for the VMs, we've also added a few new features like update management tracking, like change tracking, and inventory tracking of all the software on the VM. So it becomes really easy for you to get an overview of how your VMs are, if anybody in your organization has changed anything on that. So let's quickly take a look at how this all works. Okay. So here I have a VM. This is a Windows VM, and this works for Windows and Linux VMs both. Right, so for first, let me show you the Windows VM. So if you go down here to the update management, now what you'll see is a list of updates, and that will be ranked by critical and security that it'll show me. So it looks like I'm missing really critical security updates. So if you've been following what's going on in the media, it's never good to find out any updates you're missing in the media. So this gives you a really good overview of what updates you might be missing. And then if looks like I'm missing a few Defender updates for this VM as well. So similarly on the other side for Ubuntu VM, I can actually get a very similar experience. So in this case, this will not have any updates that is missing. Looks like it's going to take a bit of time to load. Oh, there we go. So, looks like since last time there are a few updates, missing updates. But what you can actually do is you can actually schedule a recurring update deployment. So update deployments happen on a schedule. So for example, all you need to do is, for example, if there are any updates you want to exclude or schedule settings, it's going to be like a one-time. You can specify one time, or it could be a recurring update. So I did one update on this VM last time around, so it shows you, gives you how much of a maintenance window you wanted on that update. A really nice view, and then the update succeeded. So if I click on that update, basically what it's going to show me is, if I take a look at the output, what that update basically did is basically ran sudo get apt-get update on that VM. So it should be somewhere in here. So there we go. So it ran a sudo apt-get update on that VM, and then you can set that up on a schedule as well. So it becomes really easy to keep your VMs updated. Now the next capability that's been introduced is an inventory. So the same solution that gets deployed on the VM, it can also give you a quick inventory of what's installed on this VM. So for example, here's the list of all the stuff that's installed on that VM. All these different software. So if you're looking for a particular software, you can come in here and take a look at it. So for example, IIS, it'll drill it down. So same thing with Ubuntu. So while that is loading, let me move over to the change tracking view. So this basically gives you a time scale of changes that happen to that VM. So for example, on the last 7 days, I can drill down. There's like a lot of activity that's happening in here. So 49 different software were installed. So let's take a look at this. So it looks like a lot of these different services and software were installed in that time frame. And the experience is very similar for the other side, the Linux side as well. So nothing in the last 24 hours, but if I go back to this last 7 days, looks like there's a lot of stuff happening in here in this time frame. So let's just quickly drill down to that. And what you can actually do with change tracking is not just watch for the default metrics. You can actually set up your own metrics. So for example, if you go to edit settings, what I did was I set that agent to watch for any changes to my home directory. So for example, if you look in here, custom, and I gave a path of -home-k, that's my home folder. So any changes to that got captured in this change tracking. So for example, if I, let's do search for K, hopefully this. So it looks like there's a few new files that were created in my directory. So that becomes really easy for you to tackle any changes, and you can also define your own custom paths that you want to track. All right, so let's switch back to the presentation.
Oh, there, sorry.
All right, so takeaways. So we've looked at the infrastructure, the new VM sizes that we've added, and the new disk sizes that we've added. So for availability, we looked at the new concept of zones and how we're making your applications highly available, how we make the hardware run better. And then for security, we looked at the confidential computing, how that provides really top-level, top-notch security for your applications. And we talked about MSI and how that makes things simpler. And then for manageability, we looked at the updates to the VMSS, and then looked at how we are improving the VM monitoring experience inside Portal.
And there's a whole load of previews that we announced that you can go try for yourself. So check these slides, contact us, and we can get you started on these previews.
Right. And then we have a whole lot of sessions that are related to if you're looking to get more knowledge in this infrastructure and compute. So here's one session that's right after this one, which goes up to and spins up 1,000 VM scale set.
Yeah, this one, can you go back to that
Sure.
just for a sec? This one is basically no slides, just one big demo of deploying a 1,000 VM machine learning infrastructure from scratch. So this is if you're interested in like Azure infrastructure, and you're bored of slides, this is a great demo to go and watch.
Yeah.
So this is starting in a few minutes.
Right. And please do evaluate this session and give us feedback so we can improve on other stuff that you would like to see.
Yeah, we've been told they're not getting enough evaluations, and that we should really plead with you to evaluate.
Yes. And we have a whole lot of other sessions. If you download the slides, I have like 3 slides worth of related sessions that you might be interested in that are upcoming later in the week, or there have already been recordings that will be available online soon. So with that, thank you.
Thanks.